Hey, how's it going, guys? TutorTom here, and today we're going to be talking about significant figures and why they matter. It actually will be one of the least important things you learn in any of your science classes, but it's something that teachers love, and they're going to love to use this on exams. So if we have 15 divided by 2.3, what does this give us? So it gives us 6.52173913. Now, after doing this problem, you look at this answer and you think, wow, that's really long. Like, where should I cut this off at, or where do I round this at? And significant figures tells us where we need to round this at. So example for this problem, since we have two significant figures in the top, meaning we have two non-zero digits, and in the bottom we also have two non-zero digits, what we're going to end up getting, since they both are 2, is we're going to round it to 2 units. So we would actually cut it off right here and cut off all this right there. So that's just kind of an example to show you why we need to use this and what your teachers are going to be expecting of you on your tests and your answers. But to go into the specific rules, the first one is non-zero digits are always significant. As I kind of showed up here, any number besides 0 is going to be a significant figure, and you have to include that. Number 2 is any zeros between two significant digits are significant. So if you have 100 and 1, you have 3 sig figs. But say if you just had, say if you just had 100. If you just have 100, all you're going to have is 1 sig fig right here, because both these zeros are going to be not significant. Now the last rule is a final zero or trailing zeros in the decimal portion only are significant. So what does it mean by that? So if you have 4.5 and it gives you the 0, like say it gives you in a question after the decimal point there's going to be an extra 0 at the end, this 0 is going to matter when dealing with sig figs. Usually when you're actually doing the calculations this won't happen, but when they give you numbers that include a 0 in the decimal place, you're going to want to include that in your sig figs. So say if you have two numbers, say you have 230 divided by 156. Now, how many sig figs does this have, or how many sig figs are we going to divide by? Well, if you look in the top here, there are 2 sig figs, one here and one here, the 2 and the 3, because they're both non-zero, but the 0 after it is not going to be a sig fig. Now, in the bottom, we actually have 3 sig figs, a 1, a 5, and a 6. So what do we do in this case when we have 2 sig figs in the top and 3 in the bottom? Which one do we choose? Well, we're always going to want to go with the lower amount of sig figs. So say if with these two numbers here, what we're going to end up doing is using 2 sig figs because one of the numbers only has 2 sig figs. This is the same if you had 1 sig fig on one unit and you had 3 sig figs on another, you're going to end up having to use the 1 sig fig. You just go with the lowest amount that it basically requires. So let's do a couple problems with this, and I can show you kind of how it works. So let's look at these couple problems here. So the first one we have is 1.32 divided by 1.502. So let's count how many sig figs there are. So in this one, there are going to be 4 sig figs. Well, why? Well, the 0 is in the final place, which wouldn't be a sig fig if it was not a decimal. But since it is a decimal, this is going to count as a sig fig. So we have 1 here, 2 here, 3 here, and 4 here, as well as on the bottom. There's going to be 1 here, 2 here, 3 here. And why would there be 3 here? Why is this 0 here count as anything? Well, it's because it's between two sig fig numbers. And that's the 5 and the 2. Since it's between and sandwiched between these two, it's going to count. So we have 4 sig figs. So when we calculate this out, this is equal to 0.878 8, and then 2. So we're going to be rounding up to this place right here because this is the fourth significant figure in this, and the 2 rounds up to still be 8. So it'll just stay this number, and this is our final answer here. Now, what do we do when we're having addition or subtraction? And that's what we're going to be dealing with in these next problems. Well, with addition and subtraction, what you're going to be doing is the same thing. You're going to be looking for the lower amount of sig figs in the equation. So for this one, this only has 2. So even though this one has 3 here, you're going to be using 2. So it's going to come out to 3.7. But you wouldn't carry the 0 because this one only has 2 sig figs while this one has 3. Now what about this one? 5.78 minus 3.0289 or 98. Well, this is going to end out equaling 2.11. Shoot, I can't draw today. 502. So we're going to count how many sig figs we have in this. So in this one we have 3, and in this one we have 1, 2, 3, 4, 5. So we have 3 in this one and 5 in this one. So we're always going to go with the lower amount. So we're going to take 3. So these two numbers are going to be cut off because they don't round up to anything. So these are going to be our final answers. So now that you understand how sig figs work, it's going to be a lot easier in your chemistry, your physics, or any other classes that really requires you to know this, because I know a lot of teachers are critical out there, and I've had teachers myself who have tried to mess you up with sig figs just to make you get the answer wrong. Kind of testing your capabilities, even with the small stuff. So this is one of the most useless but important things to know when you're taking your courses. So I hope you all did enjoy. If you did, please leave a like and a comment, and please subscribe. I'm going to be uploading more videos pertaining to physics. I'm actually thinking about doing this biology and chemistry series, but we'll have to get to that in the future. But anyways, I'll talk to y'all later.